Here's another function that we have where we're given a lot of details and we want to sketch a picture of what this could look like. So first of all, we have some end behavior. So as x goes to negative infinity, so as we go far out to the left, we are going to stop at the y value 0. And as we go far out to the right, we're also going to stop at the y value 0, which makes sense because this is a bottom-heavy function. Bottom-heavy, remember limits at infinity, bottom-heavy was the best. The limit was always 0. So as we go out to the left and to the right, we're going to stop at 0. I'm just going to note that on the graph down here. So I'm going to do some dotted lines at the y value 0. As we go out to the left, pretty far, we should look like we're approaching 0. And then we're given our asymptotes. The horizontal asymptote is at y equals 0. That comes from the limits at infinity. And then the vertical asymptote is whatever makes us divide by 0 that we cannot factor and cancel. So that vertical asymptote is at x equals 1. That makes us divide by 0. When we plug into the original, we'd get 2 divided by 0, and we'd see we have a number divided by 0. It's definitely a vertical asymptote. So just some good review of how to get those horizontal and vertical asymptotes. So I'm going to graph that x equals 1 line. So we have a vertical line at x equals 1 that we're going to not cross with any y values, because when we plug in, we get 2 divided by 0. So there's not going to be a y value above or below. We're just going to approach that line. All right, so we have our vertical asymptote at x equals 1 and our horizontal asymptotes as we go out to the left and to the right, we're going to approach 0. And then as far as our sign chart, for increasing and decreasing, we are never increasing and we are decreasing before 1 and after 1. So I could definitely make that into a sign chart if that's helpful. You don't have to make sign charts. I just usually like to. We're decreasing before and after our critical number. So decreasing to decreasing, which means we don't get any relative extrema because our one and only critical number, the one place where we could possibly switch increasing and decreasing, we don't. So that's kind of a bummer because those relative extrema gave us points on the graph, which helped us to draw it pretty accurately a little bit easier. So we're not given any points for relative max or min, so we don't have anything to plot quite yet from that. And then concavity, we're given concave up from 1 to infinity and concave down from negative infinity to 1. So let's draw that with our sign chart. So we're concave up from 1 to infinity, and we're concave down from negative infinity to 1. So let's figure out what this graph looks like. So this part says it's decreasing and it's concave down on that interval, comparing our first and our second derivative. So we want to draw our concave down and pick the one that is always decreasing. Is it the full upside down U? Is it the left side or is it the right side? So we want to pick, is it the first, the second, or the third picture that's always decreasing? Well, this one switches from increasing to decreasing. This one's increasing and then this one's decreasing. So we want to draw this shape. So at first the graph is going to be decreasing and concave down. That's the first part. It has our vertical asymptote at x is 1. And then on the other side, it's decreasing and concave up. So we want to draw our 3 U's. We already did for concave down. Now we want to do it for concave up. We have a full U. We have the left side of the U. We have the right side of the U. We want to figure out which one's decreasing. It's going to be this second picture here. This one's falling left to right. So on the other side, it's going to look like this. So to sketch it off to the side before we put on there, we have decreasing and concave down to decreasing and concave up. So we have a pretty good idea of what it looks like, but there's no inflection point to plot either. Why would that be? We have the change in concavity that we need on our sign chart, but remember when you plug in 1 into the original function, you'd get 2 divided by 1 minus 1, which is 0. So that's why there's no point of inflection. Even though you have that change in concavity, it's not a point on the graph because it's a vertical asymptote. So we know exactly what the graph should look like shape-wise. It's this picture over here. It should be decreasing and oriented downward and then decreasing and oriented upward. But we have no idea of where to draw it because we don't have any points. There's no relative extrema and there's no inflection point. So we're going to need to pick some random points to plot ourselves to figure out exactly where to put this. So let's pick some points. So our function is f of x, which is 2 over x minus 1. So if we want to think about what's happening over here, we want to draw this shape, and we can figure out where it would be drawn. It's definitely not going to be drawn up here because this is only approaching the vertical asymptote. It would have to be drawn somewhere in here to be approaching both our vertical asymptote and the horizontal asymptote approaching 0 as x goes to negative infinity. So we know where it should be drawn, which quadrant it's in. But to get exact y values, we could plot a point over here to figure out exactly where to put this piece. So we could choose any number over here. Maybe I'll plug in f of 0 to see what that y value would be. So f of 0 would be 2 over 0 minus 1. So you'd have 2 divided by negative 1, which is negative 2. So f of 0 is negative 2. So you kind of know where to draw it. We can plot more points on here if we want to. Maybe plug in f of negative 1. So that'd be 2 over negative 1 minus 1. So we'd have 2 over negative 2, which would be negative 1. So there's a couple points over there just to give us an idea of where to draw it. And then we could just draw something decreasing and oriented downward, approaching both of our asymptotes. That approaches our horizontal asymptote, and this is approaching our vertical asymptote. And then same thing to the right side. We can figure out which quadrant it has to be in. It has to be this shape, so we could either pick to put it up here or it could be down here. So you don't have to draw both. We just need to figure out which one it's going to be. Is it the top one or the bottom one? It approaches both the vertical asymptote and the horizontal asymptote. It would have to be the top one. This bottom one doesn't approach y equals 0, but the top one does. It approaches our horizontal asymptote as well as our vertical asymptote. So we want to draw that shape, but we can plug in some points to figure out where to draw it. So we have our function 2 over x minus 1. Maybe we could plot the number f of 2. Just plugging in points all over the place here. We have 2 divided by 2 minus 1. So we have 2 over 1, which is 2. So the point 2, 2. And we could plug in another point if we want to. You could plug in f of 3. Move a little bit over. 2 over 3 minus 1. We'll get 2 over 2, which is 1. So the point 3, 1. And now we can just draw our general shape. Decreasing, but concave up. Approaching both our vertical asymptote and our horizontal asymptote. So lots of work even being given all this information. This one was a bit more work just because we didn't have any points that were given to us. So we knew the general shape of the graph from looking at our sign charts, but then we had to figure out where exactly to put them by plugging in a couple points within that part of the graph.